Welcome to the TOEFL Listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Dr. Elena. Thanks for meeting with me during your office hours.
Hello, Alex. No problem at all. You mentioned you wanted to discuss computational photography advances for your class project.
Yes. I am interested in AI-enhanced image processing techniques, but I am not sure which subtopic to choose. There are so many recent advances.
We can narrow it down. Computational photography advances focus on combining optics, sensor data, and algorithms to improve images. In recent years, deep learning has transformed tasks like denoising, super resolution, deblurring, HDR merging, and depth estimation.
That matches what I read. Could you explain how multi-frame methods like burst photography relate to AI techniques?
Burst photography acquires a sequence of short exposures, while the sensor moves slightly. Multi-frame fusion algorithms align frames and combine them to increase signal-to-noise ratio and dynamic range. AI models can learn alignment and fusion jointly, which improves low light and HDR performance compared to classical pipelines.
So, deep networks handle both alignment and reconstruction at once?
Exactly. Methods using convolutional neural networks and transformer blocks can estimate motion and fuse information across frames. Some rely on optical flow, others use learned features to avoid explicit flow estimation.
What about single image approaches like super resolution or deblurring with generative models? Are those still important?
Yes. Single-image super resolution has advanced through adversarial networks and perceptual losses. That includes GAN-based models and more recently diffusion models that generate high-frequency details. Deblurring uses synthetic blur kernels for training, and self-supervised approaches are emerging as well.
I heard about diffusion models a lot lately. How do they compare to GANs for image restoration tasks?
Diffusion models tend to be more stable during training and can produce diverse, plausible reconstructions. They're computationally heavier, but they reduce mode collapse that plagued early GANs. For restoration tasks, they can be conditioned on degraded input to iteratively refine output, which helps avoid obvious artifacts.
Are there standard data sets we should use for training and evaluation?
There are. For deblurring, the GoPro dataset is common. For low-light denoising, we often use the SIDD dataset, which contains real noisy images and ground truth. For tone mapping and exposure adjustments, the Adobe 5K dataset is widely used. Choosing appropriate datasets matters because synthetic data can bias models.
Which metrics should I report in the project? I know PSNR is common, but I read that it is not always aligned with perceived quality.
Good question. You should report PSNR and SSIM for objective comparisons, but include perceptual metrics like LPIPS as well. Visual quality and user preference are important because models optimized for PSNR can look over-smoothed, while models optimized for perceptual metrics may introduce hallucinated details.
When you say hallucinated details, do you mean the model invents textures that were not in the scene?
Yes. Generative restoration models sometimes synthesize plausible texture that is not faithful to the original scene. That is why a small user study is useful to detect perceptual problems that PSNR and SSIM do not capture.
How should I design an experiment to compare methods?
Start with clear baselines. Include a classical algorithm such as non-local means or BM3D for denoising. Then include a recent deep model and perhaps a diffusion-based method. Use the same training and testing splits. Report PSNR, SSIM, LPIPS, and runtime. Finally, run a perceptual user study with a small set of participants to rate quality and realism.
Do you recommend training models from scratch or fine-tuning pre-trained networks?
Fine-tuning pre-trained models is efficient and realistic for a semester project. Many state-of-the-art models provide checkpoints. Fine-tuning on your target dataset shortens training time and often yields strong performance.
What about on-device deployment and the camera ISP pipeline? Should I consider that for the project?
It depends on your scope. Demonstrating a model running on a mobile CPU or GPU is impressive, but adds engineering complexity. You could simulate ISP input by supplying raw or linearized sensor images and mention deployment as a discussion point. If you focus on algorithmic advances, you can leave deployment for future work.
I am leaning toward a project on multi-frame low-light fusion with a learned alignment module and a perceptual loss. Does that sound feasible?
That is a solid choice. It touches on burst photography, denoising, and HDR merging. Make sure to define evaluation criteria, include classical and learning-based baselines, and justify your loss choices. For perceptual loss, consider LPIPS, or feature losses from pre-trained networks.
Should I include ablation studies to show the effect of alignment or loss terms?
Yes. Ablation studies strengthen your claims. For example, train with and without the learned alignment, and with L1 loss versus perceptual loss. Show how each change affects PSNR, SSIM, LPIPS, and subjective ratings.
Are there ethical considerations I should mention in the report?
Mention that generative enhancements can change the factual content of an image, and that applications like forensic analysis require conservative restorations. Also discuss dataset bias and the need for diverse training images so systems work across skin tones and lighting conditions.
This is very helpful. For the user study you suggested earlier, what size and procedure would be reasonable?
A small study of 20 to 30 participants is adequate for a class project. Use pairwise comparisons between your method and baselines, randomize order, and ask participants to rate realism and preference. Report statistical significance when possible.
Okay, I will prepare a plan and a timeline. Could I show you a short proposal next week?
Yes, please. Bring a one-page proposal with objectives, datasets, baselines, metrics, and a schedule. Also include a note on compute resources so I can advise on model sizes.
Thank you, Dr. Elena. I will start with SIDD and GoPro and draft the proposal.
Good. Remember to justify metric choices and plan a perceptual evaluation. I look forward to seeing your proposal next week.
Listen again to part of the conversation, then answer the question.
Do a small study because PSNR and SSIM can miss hallucination artifacts introduced by generative models.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.